Assalamualaikum. My name is Nushakira binti Ibrahim. My metric number is 203-991. So today I would like to present about the Newton's law of motion, which is a Newton's first law and Newton's second law. Okay, Newton's first law states that an object at rest will remain at rest unless it acting by a force. So for example, we have a surface and there's a box on the surface. If we not apply any force to the box, that means that the box will not moving. Force that acting on this box will become balanced. For example, we have a weight force which is equal to mg, and we got the weight force is equal to 98 Newton. So we have the other force that keep rest, which is a normal force, and the normal force is also 98 Newton. It is because in order to keep the box will not moving. So as you can see, this balance force and the net force is equal to the 0. Next is a Newton's second law. Newton's second law states that an object in motion will continue in motion unless acted on by a net force. So let's say we have the rough surface and the ball moving to the right side, and we know that the ball going to stop quickly and not going to move very fast. This is because we have a friction force between the surface of the ball and with a rough surface, and we know that a friction is opposite direction. So according to the second law, that states that the net force is equal to the product of the mass and the acceleration. So if we increase the mass, so the net force also increase. Same goes to the acceleration. If we increase the acceleration, so the net force also increase. So this is the note that we need to remember from this chapter. If object remain at rest, then the net force is equal to 0. And if object moving with constant velocity, then the net force is equal to 0. And if the net force is not equal to 0, there exists a net acceleration. So let's look at the example. A car travels on the road with a constant velocity. What is the horizontal net force acting on the car? So we know that the question already states that the constant velocity, that means that the net force will be 0. From the previous slide, we know that the net force is equal to 0. B, what is the acceleration on the car? So from the Newton's second law, we know that F is equal to ma. So if the net force is equal to 0, that means that A is also equal to 0, because F and A is directly proportional. C, if the frictional force acting on the car is 1,500 Newton, what force is applied to the car by the engine? So let's make a diagram. We have the box here, and it represents as a car. So let's say car is moving to the right side, to the right direction. So friction, we know that it is an opposite direction. So friction force is equal to the 1,500 Newton based on the question given. Now the net force is equal to 0. We know that from the question A, the net force is equal to 0. That means that the force that applied must also equal to friction force, which is 1,500 Newton. So it is to balance the force so that the net force will equal to the 0. So the answer is the force applied is equal to the 1,500 Newton. So that's all for me. Thank you.
Assalamualaikum and hi everyone. My name is Nur Hidayah binti Hamzah and my metric number is 203-963. So I will explain a question from tutorial 1, which is in chapter 3, question 3.9. So the question is, a physics book slides off a horizontal tabletop with a speed of 1.1 meter per second. It strikes the floor in 0.350 seconds. Ignore the air resistance. Find A, the height of the tabletop above the floor. So before we answer the question, we are encouraged to draw or sketch the situation so that we might be more clear on what the question would be like. So based on this drawing, we can know that up here is the initial location for the physics book, while down here is the final location of the physics book. So based on this drawing, we can consider that this as a projectile motion. And condition for the projectile motion is the horizontal acceleration must always be 0, while the vertical acceleration always be negative 9.8. So after that, we are encouraged to list out all the information for each component, which is x component and y component. So for the x component, we know the acceleration is 0 and the initial velocity is the velocity or speed that given in the equation, which is 1.1 meter per second. So the acceleration for y component is negative 9.8, while the initial velocity is 0. And lastly, the time taken is 0.35 seconds. So back to the question, it asks us to calculate the height of the tabletop. So we can use this formula based on the information given. So we use the formula Sy equal to Uyt plus 1 over 2 Ayt squared. So we insert all the information given into the equation. So we can get the value of Sy is negative 0.6 meter. Negative sign here shows that the tabletop slides off the horizontal tabletop to the floor. So that's why there is negative sign in the value of Sy. But the question asks us to calculate the height. So the height must always be positive value. So the height is 0.6 meter. Next, the horizontal distance from the edge of the table to the point where the book strikes the floor. So we can use the same equation or formula, which is Sx equals to Uxt plus 1 over 2 Axt squared. So we insert all the information given and we managed to get the value of Sx is 0.385 meter. So the horizontal distance is 0.385 meter. And lastly, the question asks us to calculate the horizontal and vertical components of the book's velocity and the magnitude and direction of its velocity just before the book reached the floor. So firstly, we need to find what is the velocity for the horizontal and vertical components. So based on the information given, we can use the formula Vx equals to Ux plus Axt to find the horizontal velocity. So when we put all the information given into the equation, we managed to get the answer or the value for Vx is equals to 1.1 meter per second. Next, to calculate the Vy, we can use the same formula. Then we insert all the information given and we managed to get the value of Vy is negative 3.43 meter per second. Then next, when we get the horizontal and vertical velocity, we need to find what is the resultant velocity. So to find the resultant velocity, the formula is set Vx squared plus Vy squared. So when we put the Vx and the Vy value into the formula, we managed to get the resultant velocity is 3.6 meter per second. Next, to find the direction of velocity, we need to use the formula tangent y equals to Vy over Vx. So, then we managed to get the theta equals to negative 72.22 degree. Negative sign here shows that the direction is below the horizontal, not above, because there is negative sign here. So lastly, the result we get, the magnitude of the velocity of the velocity is 3.6 meter per second and have direction of 72.22 degree below the horizontal. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good evening to everyone. My name is Muhammad Shahidani bin Muhammad Nafi and my metric number is 201134. So I will present this question, which is question 5. Actually, this question is related to the chapter 5, which is called Applying Newton's Laws. So let's read the question first. A 45 kilogram The 45-kilogram crate of tools rests on a horizontal floor. You exert a gradually increasing horizontal push on it and observe that the crate just begins to move when your force exceeds 313 Newton. After that, you must reduce your push to 208 Newton to keep it moving at a steady 25 meter per second. So for the first question, we are required to find the coefficients of static and kinetic frictions between the crate and the floor. So actually we have two situations here, which is at fast and also at it moving, but at steady at a constant velocity. So basically with these two situations, we need to apply the Newton's first law, which means that the total of force, the net force, it would be equals to zero since it is in equilibrium. So to make it clearer, we can refer to this diagram which let's say that this is a y component and this one is x component. So for x component, we have force to the right side and then friction force to the left side, and then for y component, we have n normal force to upward and downward it would be the mg. So actually from this diagram, we can create two equations lah. We can create two equations. So to answer this question, we need to understand what is the difference between static and kinetic frictions. So generally, we can see that static friction it involves before the object starts moving, and kinetic friction will involve once the object starts moving. So let's focus on the first situation first. So for the first situation, the object is at rest, and we have to find the coefficient of static friction. So from this diagram, we can create two equations, which is for x components and also y components. So for x components, we can create this, which is force 1 minus force static friction force maximum equals to 0. And the second equation, it will be n minus mg equals to 0. Why it has to be equals to 0 is because the object is at rest, so that's why it has to be equals to 0. It is in equilibrium. And also here, the force, the static force, it has to be maximum because the force that we need to apply, it has to overcome the maximum static friction force so that the object starts moving. So once we have two equations, this and this, so we can move this to the right side. So we will have this, and then we just insert the formula for static friction force, which equals to mu s multiplied with normal force. So normal force here, actually we can get this from this equation, which means that we need to move mg to the right side, and then we will have this, and simply we can just insert this into this equation. So we will have mu s multiplied with mg. So since we have to find the coefficient, we need to move mg to the left side. So we will have this equation. So then we just need to insert the value for each part, which is 313 Newton for the force, and then over with 45 kilogram multiplied with 9.8 meter per second. So as we calculate it, we will have 0.71. So this is coefficient for static friction force. So for the second situation is the object already moving but at a constant velocity. So same as before, the method is the same, which means that the second force minus with Fk, which is kinetic friction force, equals to 0, and also n minus mg equals to 0 because it is in equilibrium. And then we need to move this to the right side, which is Fk, and then we just insert the formula here, mu k multiplied with n, and here we can get this from this equation. So n equals to mg, insert this into this equation, we will have this. So we need to find the coefficients, right? So we need to move mg to the left side, so we will have this equation. Then once we have this equation, we just need to insert the value. So the force here, it has to be 208 Newton over with 45 kilogram multiplied with 9.8 meter per second. So as we calculate it, we will have 0.472. So as we observe here, actually coefficient for static friction force is higher than kinetic friction force. Why? It's because static friction force is higher than kinetic friction force. That's why the coefficient here is higher than this one. So that's all from our group. I hope that our presentation can give you much informative information to all of you. And also thank you for
Right,
listening.
thank you, Shahil, for the great explanation. So I will continue to explain on chapter 8. I'll choose question 8.23 from tutorial 3. The question before that, my name is Hidayah binti Abdul Aziz and my metric number is 204160. Two identical 1.50 kilogram masses are pressed against opposite ends of light spring of force constant 1.75 meter per meter. The spring by 20 centimeter from its normal length. Find the speed of each masses when it has moved free of the spring on a frictionless horizontal table. And the first information that we can interpret from the question is the momentum and mechanical energy are conserved. Second, the mechanical energy consists of the kinetic energy of the masses and the elastic potential energy of the spring. Last, the third one is the potential energy stored in the spring is transformed into kinetic energy of the two masses. Then we have take out all the information and the value given. We have the mass 1.50 kilogram, the force constant K 1.7 Newton per centimeter, length of the spring is 20 centimeter, and the person asked to find the speed of both masses. So to make it clear, I will show you the diagram, the initial and the final situation. The situation is the A and B is pressed together, and after that both of them go on two opposite direction. Then from the law of conservation momentum, we know that P1x is equal P2x. Then to just put all the information in the formula. And if you notice the negative and positive sign from two in at the VA and VB is because we assume that if the mass go to the right, we put positive sign, and if the mass go to the left side, we put negative sign. And since we know at the earlier, since the masses are equal, so we can conclude that VA also equal to VB. And energy conservation says that potential energy originally stored in the spring is all converted into kinetic energy of the masses. So we can conclude using this formula. And since we already have all the information and the value, just put all the information. And if you notice, there is no mass in the final formula because we know that both of the masses are equal. Then just put all the information, but don't forget to change to the SI unit for the force constant. And there you have it, 1.53 meter per second for the both speed A and B. But a little reminder here, this situation is when both of the mass are equal. That's why we have the only one. We can use the equation VA equal to x1 set K over 2m. But if you have you have the similar situation but different mass, you can conclude that they will end up with the lighter one. The lighter one, which is the lighter mass, has a greater speed because they end up with equal magnitude of momentum. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nushaira Baitiado Anwar. My metric number is 201919. Today I will present question 10.11 from chapter 10, which is about dynamics of rotational motion. The question is, motion part has the shape of a solid uniform sphere of mass 225 grams and the diameter 3 cm is spinning about a frictionless axle through its center, but at one point on its equator it is scraping against metal, resulting in friction force of 0.02 Newton at that point. A. Find its angular acceleration. B. How long will it take to decrease its rotational speed by 22.5 radians per second? The data given is mass of sphere 225 grams. We convert to kilogram, we get 0.225 kilogram, and the diameter of the sphere is 3 cm. We convert to meter, 0.03 meter, the radius is diameter divided by 2, we get 0.015 meter. The friction force at the point is 0.02 Newton. To find the angular acceleration, firstly we have to find the moment of inertia and the torque exerted by the friction force. To calculate the moment of inertia, we use the formula 2 per 5 multiplied with m, which is mass of sphere, and r squared, which is radius of the sphere. We substitute the value of the mass of sphere, which is 0.225 kilogram, and the radius of the sphere 0.015 meter to the formula, and then we get the moment of inertia of the solid sphere is 2.025 times 10 power of negative 5 kilogram meter squared. Then we have to calculate the torque exerted by the friction force. The formula is torque equal to negative Fr. F is the friction force and the R is the radius. We use the negative sign because the direction of the friction force is opposite to the direction of spin. Then we just substitute the value of friction force, which is 0.02 Newton, times radius of sphere, which is 0.015 meter, and we get negative 3 times 10 power of negative 4 Newton meter. The angular acceleration, we use the formula of rigid object under a net torque. So to find the angular acceleration, we calculate the torque exerted by the friction force divided the moment of inertia. We just substitute the value, we get the angular acceleration is negative 14.8 radius second power of negative 2. Okay. For B, we have to calculate the time taken to decrease its rotational speed by 22.5 radius per second. So we use the formula of rotational acceleration, which is change in rotational velocity divided by time interval. So we want the time interval. So the change in rotational velocity divided by the angular acceleration that we get just now. So we just substitute negative 22.5 radius per second divided by negative 14.8 radius second, the power of negative 2, and then we get the time taken is 1.52 seconds. That's all from me.